Hello guys, I'm Kumar. In this video, we're going to say about stack implementation using linked list. The aim is to create a single linked list and implement the stack with the push, pop, and display function. Now we're going to create a class function, class name as node. And we're going to declare a node so that we're using a def init of underscore self comma data. First we're creating data so that self dot data equal data, and next we're creating in next self dot next equal to none. And next week we are creating a stack so that using class stack and definite of self and self dot head equal to none. And next we're going to push a node in a stack so that using a push function here and def push of self comma data. If self dot head is none, self dot head equal to none of data, else new node equal to node of data, new node dot next equal to self dot head, self dot head equal to new node. And next we're going to see about pop. You're going to delete a node in the stack so that using a pop function def pop of self. If self dot head is none, return none, else pop equal to self dot head dot data and self dot head equal to self dot head dot next, and print str of pop plus pop successfully and return. Then we're going to display the after pop and after many push and pops. So we're using a def display of self. If self dot head is none, then print stack is empty, return and then return. Else n equal to self dot head, while n is not none, print n dot data, then n equal to n dot next. Next we're going to do a monitor program so that using a stack s1 equal to stack and k equal to 1 and while k equal to 1, and using a first choice is push and second choice is pop and third choice is display and fourth choice is exit. If we give first choice, then it will push it will push the node in the stack. If we give second choice, then it will pop the node in the stack. Then it will display the. If we give third choice, then it will display the node in the stack. If we give choice for, then it will exit the program. Now it's asking the enter choice. I'm going to give a choice as 1. Then it's asking enter the element to be popped, pushed. So giving it element as 10. Then it's asking enter choice. Then I give 1. Now it's asking element to be pushed. So I give 20. Now it's asking enter choice. So that give a choice as 1. Then it is asking a enter the element to be pushed. So I give a 30. Then I'm going to display the all element. So that using a giving a choice as 3. Now displaying 30, 20 and 10 and I'm going to pop the node in the stack. So giving choices 2. 30 popped successfully and I'm going to pop the again, and 20 is popped successfully and going to pop again. So I give it choices 2. Now 10 is popped successfully. Then I'm going to exit the program. And next we're going to see about queue in a single linked list. So first we're creating a class and class name as node, and we're declaring a node. And next we're going to see about so definite of self comma data, creating data and none. So that self dot data equal to data and self dot next equal to none. Next we're creating a queue function, class and class name as queue, and definite of self dot head equal to none and self dot last equal to none. Then creating a enqueue. Enqueue is to insert the node in the queue. So using a def enqueue of self comma data. If self dot last is none, self dot head equal to none, node of data, and self dot last equal to self dot head. Else self dot last dot next equal to node of data, self dot last equal to self dot last dot next. Then we're going to do in dequeue. We're going to delete the node in the queue so that we're using a dequeue function and def dequeue of self. If self dot head is none, return none, or else to return to return equal to self dot head dot data. self.head equal to self.head.next, then return to return. Then you're going to display after the enq and deq. So using display function, so the display of self, it will print a q elements are getting user input like q elements are, and n equal to a self.head, and while n is not none, print n.data, n equal to n.next. Then you're going to do a many-driven program, so that you're using first choice as enq, and second choice as deq, and third choice as display, and fourth choice as enq, etc. And going to, if you give a first choice, then we'll do a enq, the node, and the q function. If we give a choices 2, then it'll do a deq. If we give a choice 3, then it will display the node in the queue. If we give a choice 4, then it will exit the program. It is asking the intro choice first. I'm going to give a choice as 1. It is asking enter the element to be enqueued. I'm going to give a element as 10. Then I'm going to give a choice as 1. And I'm going to enter element to enqueued as 20. Now it's asking an enter choice. I'm going to give a choice as 1. I am going to give a 30. Now we're going to display all the enqueued element in the queue. So giving choice as 3. Now it's displaying the enqueued element 10, 20, 30. They're going to dequeue the all element, so that giving choices 2. Dequeue element is 10, and going to give again choices 2. The dequeue element is 20. Then I'm going to give again choices 2. Now showing in dequeue element is 30. Then exit the program. That's all, guys. Thank you for watching.